In Creo Parametric, you can use Pro Program to turn your model's regeneration into an interactive process so that you can be prompted for the values of different dimensions and parameters. In a previous video, I used Pro Program at the part level. In this video, I'm going to use Pro Program at the assembly level, and I'll show you how you can use the execute construct in order to pass different values from your assemblies down into your individual components. Let me orient you to this assembly for a moment. In this assembly, I have a plate part, and that plate part has a hole in it and also has a number of holes for bolts. Then I have a reducer subassembly, and the reducer subassembly has the actual reducer component and a pipe and a bunch of bolts that fasten the pipe to the reducer. And we also have a bunch of bolts and nuts at the top level of the assembly. In this scenario, I want to control 4 different dimensions at the top level. I want to control the diameter of the hole at the inlet side and the diameter on the pipe side. I also want to control the number of bolts at the plate side and also at the pipe side. Additionally, in the subassembly, I'm going to control the height of the reducer. So those are 5 different dimensions that I'm going to control, 4 at the top level and 1 in the subassembly. So let's take a look at how to do that. First off, I am going to access program by going to the model intent overflow and then choosing program. And here in the menu manager, I'm just going to jump right to editing the design. And here we have the first section. This is the header section. Then we have our inputs, relations. Then we have our model body. And then down at the bottom, we have the 5th section for the mass properties. Let's go back up to the top. And here I'm going to write in my 4 inputs at the top level. Let me put in some spaces in here. And the first input is going to be, let's do the plate side diameter. Let's see, I'll call that the plate hole diameter. And that's going to be a number. And then in quotation marks, I'm going to put the prompt. Enter the diameter on the inlet side. And then let's put in the number of bolts on the plate side, plate, bolt, holes. And that's also going to be a number. Write the prompt. And then the third one is going to be the diameter of the hole on the pipe side. And that's also going to be of the type number. And lastly, let's put in the number of bolt holes on the pipe side. And that's going to be it for the prompt. So I have 4 different prompts that I'm writing here at the top level. Now, let's scroll down to the body section. In the body section, first we have internal feature ID 1. This is actually the first datum plane, ASM right. And then scroll down. Here we have internal feature ID 2. This is actually my second datum plane. This is ASM top. Then feature number 3 is ASM front. And feature number 4, that is the default coordinate system. Then we have our add construct for the components. First we have add part, and the part name is plate program. You can see that here in the model tree. And it just has the line for the internal component ID and then the end add. Here we have the add subassembly reducer program ASCII. That's the same name over here. And the information for that. In order to pass information down to the component, we're going to use a construct that's called execute that ends with end execute, and that's going to pass those different inputs down to the components. But before I can do that, I need to prepare the model to receive those different inputs. So let's go ahead and do that. Let's hit the save out of here. And I'm going to exit out of Notepad. Do I want to incorporate the changes into the model? Yes, I do. Now it asks me what I want to do about the inputs. I'm going to enter in the inputs because these all right now have a value of 0, seeing as I just created them. So let's plug in some initial values. So the diameter on the inlet side, let's start off with a value of 40. Number of bolts on the inlet side, let's choose 8. And diameter on the outlet, I'll choose 20. And also 8 bolts over there. And I plugged in the different values. Nothing changed because none of the models know how to use those different values. Now let's go over to the plate part so we can figure out what those values should be. So here I go into the plate part. First, I've got the hole over here. Let me click on it with the left mouse button, and then from the mini toolbar, I can use the Edit Dimensions command, and I can see that right now it does have a value of 20. I think I entered in a value of 40. But more importantly, I need to figure out what is the name of that dimension. I'll go to the Tools tab and then switch dimensions, and that is the D7 dimension. The other thing that I want to control in this part is the number of bolt holes. So let me select that, and I can see that there are two different dimensions here, P36 and P13. Let me switch dimensions, and okay, it's 6 holes in the first direction and 1 set of holes in the second direction. This is the one that I'm actually interested in. Let me switch dimensions. So that one is P13. So I want to control those two different things. Also, if this diameter changes, the diameter of the bolt hole circle should change as well. Let me take a look and see what that dimension is. Let me select the first hole in the pattern and then edit. And that looks like it is the D10 dimension is the one for the bolt circle diameter. All right, so in order to have this be driven by the next higher level, let's go to the program. I will go to the Model Intent Overflow and then choose Program and Edit Design. And then in here we have the inputs. Here we're going to put the names of the dimensions D7 and P13, since I'm going to assign those two different values. So let me put in here. In this case here, we're not going to specify what type it is or write a prompt. I'm just going to put in the names of the dimensions, D7 and P13. And then let's have the different, that's all I need to do in here, but I do want to add in that relation so that the bolt circle does adjust when D7 changes. So that dimension was D10 for the bolt circle diameter. I'm going to put in a couple spaces just to make it easy to read. D10 is going to be equal to D7. I'm going to add a value of 6 for the bolt circle diameter. So that is good. Let's choose File Save and then File Exit. Do I want to incorporate the changes? Yes. And I'm just going to see if I can get out of this with current values. So now that I've updated the part model, now let's go back up to the assembly in order to pass the entered values at this level down to the plate. So once again, I will go to the Model Intent Overflow and choose Program, Edit Design. Here we have our different inputs. Let's scroll down over here, again past the default datums, and this is where I want to put in that execute information. So we'll start with execute part, and then it's going to be the name of the component, plate-program. And then we're going to put in the different dimensions, those inputs that are going to get the values of the parameters that were entered here. So D7, that is going to be equal to the plate hole diameter. And then that P13 dimension, that's going to be equal to the plate bolt holes. And then we'll type in and execute. And just to be sure, just want to check the names here, plate hole diameter, plate bolt holes. Just make sure they match up. Plate hole diameter, plate bolt holes. That is good over here. So now let me scroll down just to show you once more. So again, execute, type of component, the name of the component, the relations that are going to pass the values from the assembly level down to the individual component, and then end execute. All right, let's hit File, Save, and File, Exit. Do I want to incorporate the changes? Yes, I do. And now let's enter in the values. Let's select all again, and then done select. And so enter the diameter on the inlet side. Let me just do something slightly different to the model. We'll update 36. Number of bolts, let's do something weird like 5. Enter the diameter on the outlet side. How about 24? Number of the bolts on the outlet side, we'll do 7. And I hit that, and you can see, okay, so the diameter updated, the number of holes updated inside of here, but right now it doesn't match up with the subassembly. So let me just hit done return out of here for a moment. And now what I'm going to do is hop over to the subassembly and prepare it to enter the values, and also have a prompt for the height dimension. So let's go over to the reducer subassembly. I will choose the open icon from the mini toolbar. And now over here, let's go to the Model Intent Overflow and then choose Program and then Edit Design. And so here we have our input section. And so what I'm going to do is I'll just type in the names of the inputs that are going to come over from the higher level assembly. Now I'm going to use the same name. That will make things easier on me. Let me choose plate and let's see, hole diameter, and plate, bolt, holes, and then pipe, hole, diameter. And essentially what I'm doing here is it's essentially initializing the different variables in here. And I said that I wanted to have the height entered in at this level. So let's create a variable called height of the type number and type in the prompt, enter the height of the reducer. So that is good for that. Let me click Save and Exit. Do I want to incorporate the changes? Yes, I do. And let's enter in the values. Here we have all of them listed because it thinks that these different variables only exist at this level. That's fine. Let's just select all and then done select and just enter in some different values here. Hey, for the plate hole diameter, let's use a value of 20. Number of bolt holes, let's use 8. Pipe hole diameter, let's use a value of 10. And the number of pipe bolt holes, let's use a value of 8. And the height of the reducer, let's use a value of, I don't know, 60. And I entered in those different values and then hit done return, and nothing happens in here because, again, all we did was we inputted a bunch of different values. We haven't assigned them to anything or passed them down from the next higher level. Let me hop over to the reducer real quick and just want to mention something that'll help you out later on. Okay, with the plate, I looked up the names of the different dimensions and I saw that we had a D7 dimension for the diameter of the hole. We had a P13 dimension for the number of the instances. One way that you can make things easier on you is by changing the names of the dimensions from whatever Creo Parametric assigns to them to the actual name of the variable that you're using, and that saves you from having to write a relation. So I'm going to go to, I happen to know in this particular model, the datum plane controls the height of the reducer. Right now it has a value of 20. Let me go to Tools and then Switch Dimensions. Right now, that is the D3 dimension. If I click on it, it brings up the tab for the dimensions properties. And over in here, I'm going to change it from that default. I'm going to change it to the name height. And so there you see it change on the screen. That is good. And that's just going to save me a step in a couple minutes. But let's go back up to the, let's see. At this point, I want to go back to the actual upper level assembly over here, and I want to use that execute statement in order to pass the 4 different variables at this level down to the subassembly. So let's go to down over here. All right, so here's the D7 and the P13 that I did. And here's the add and end add. And in here, this is where I'm going to put in the execute for the subassembly. So let's type in execute. And you don't type in subassembly like you have here. This is actually the type assembly. And the name is reducer program ASCII. And the different ones I'm going to pass to it: plate, hole, diameter, plate, bolt holes, and pipe, hole, diameter, and pipe, bolt, holes. I'm going to pass all 4 down to the subassembly, and then let's type in our end execute. And again, might want to just double check every time that you do this to avoid errors, just to make sure that the names match up with what you are passing. Otherwise, you will get an error. So that is good. Let's choose File, Save, and then exit out of here. Oh, it says I've got an error. Let's try to edit and see what I did wrong. So now we will scroll down over here. And most likely case is typing. Oh, here's what happened. I just wrote the names of the variables. I need to actually write that this on the component side is going to be equal to the same name. So again, it's passing what's on the right at the higher level down to the lower level. Yeah, so it does have a syntax checker which will flag you to different mistakes that you make. Let me save and exit. And when you get this prompt, you want to incorporate your changes into the model. Pretty good sign that you entered in everything correctly. So let's enter in some new values here. Select all, done select, and let's see, diameter on the inlet side. Let's use a value of 30. Number of the bolts here, let's change that to 8. Diameter on the outlet side, let's try 20. And the number of bolts on that side, let's choose 6. And now we get this other one where it's like it's prompting us again because I added another prompt at the subassembly, so it wants to know what I want to do down at the subassembly level. So let's choose enter. And here is that variable height. I'm going to enter in a value for it. Right now it has a value of 60. Let's change that to a value of 40. And again, you'll notice that not much updated except for what was going on in the plate because we're not yet driving the subassembly by the different values. Oh yeah, you'll also notice we got a regeneration failure. That should resolve itself in time. But let's go back to the subassembly to start driving different values in here. So let me open up the subassembly in its own separate window. Let's now go to the program command and I will edit the design. And so again, we're passing down 4 different dimensions or variables from the top level. We're entering in another different one. There are no relations that I want to write at this level, But let's scroll down. We've got our default datums up here at the top. This is the default coordinate system. Okay, so now we're back down to where we're going to pass values to the reducer. So let's write execute, and let's see, part, and the name of the part is reducer-program. And I think the only thing I changed so far was the height, so that's the only one I'm going to pass. I'm going to pass height equals height. Let me make sure I spell it correctly. And then end execute. So right now, this is just going to pass that height dimension to the height variable here at the subassembly level down to the part. And since I changed the name of the dimension that control that datum plane to height, then I don't have to write a relation down at that level. So let's see if I did everything correctly so far. Save and then exit. Yes, I want to incorporate the changes. Let's try using current values. And now let me go back to the reducer and fix that to make sure that it is being driven correctly. So on the Tools tab, you also have a model intent overflow that you can use to get to program. Let's edit the design. And so here I need to put in the different inputs. And this is actually going to have 5 different inputs, all the ones that we created earlier, including that height one. But we have the plate hole diameter. We have the plate bolt holes, and we have the pipe hole diameter and the pipe bolt holes. Now earlier I figured out which different dimensions need to be driven by this. So let's go ahead and write in those different relations. So for example, I know that the number of holes in the plate, that's actually the P11 dimension, and that's going to be equal to plate bolt holes. And the corresponding dimension on the pipe side is P36, so that's going to be equal to pipe bolt holes. I also figured out which dimensions in this particular part correspond to the plate hole diameter and the pipe hole diameter, so let's assign those. I know that the D45 dimension in the model, that should be pipe hole diameter. And the way I figured that out was the same way that I did it on the pipe side. I just selected the different features in the model, went to edit dimensions, and oops, got that wrong. Let's see, D45, this should be plate side. This should be pipe side. Yeah, I just went to edit dimensions and figured out what those different dimensions were. All right, also in here, I need to write some relations that'll control the bolt circle diameter as well as the outer diameter of the plate. If I want to, I will put in a comment line, /* control outer diameters of flanges and bolt circle diameters. And let's see, the D1 dimension, that is going to be equal to D45 plus 10, and also the D8 dimension, that's going to be equal to D47 plus 10. In other words, make the diameter of the flanges just bigger than the diameters of the holes. And also along with that, I'm going to have the D5 dimension, that's the one that controls the bolt circle diameter. That's going to be equal to D45 plus 6. And the other one is D31. That's going to be equal to D47 plus 6. So again, bolt circle diameters. And again, all I'm doing is I'm taking these inputs from the higher level and then having them drive the different part level dimensions. Let's see if I typed everything correctly in here. Let's choose save and then exit. Yes, I want to incorporate. And just to test this all out, let's enter in the values here at this level. So I will choose all the different dimensions. And for the height, let's try a value of 40. For the plate hole diameter, let's try a value of 40 there. For the number of bolt holes, let's use a value of 10. The pipe hole diameter at the top, let's use 15. And the number of bolts at the top, let's use 3. And so there you can see, wow, this looks really, really weird. I think I got one of the relations wrong because this top flange shouldn't be that big. So let's take a look at Edit Design, and let's see over here. Okay, so I did get a couple of the different dimensions wrong. This one, I switched my D5 and my D8. This should be D5, and this should be D8. Let's try that. File, save, and exit. Yes, I want to incorporate the changes. Let's use the current values. There we go. That looks much better in here. So we have it looking like a reducer, an odd looking reducer, but it does look like a reducer. So in that way we have things being controlled at this level properly. Let's hit done return out of here. Let's close this and hit the regenerate button. Let's use the current values. Actually, let's enter in the values in here. Select all and there we go. So again, we have the reducer updating. Right now, the pipe isn't being driven by the different values in here. So we have to make sure that the pipe also works as well. So you can see that we're actually, this is a bit of work that I'm doing here to drive everything at the top level. So here we have the pipe. This is actually a family table instance. So rather than using open from the mini toolbar, I'm going to hold down the right mouse button to get the pop-up menu to use open generic. And again, I'm going to open the generic from the select instance dialog box. In another video, I will show you how you can use Pro Program to select different instances of the family table. But again, there's a lot of information in this video, so I'm not going to be able to show that in this particular one. So let's now set this up for Pro Program. So let's go to the Model Intent Overflow and then choose Program and Edit Design. And for the inputs on here, we're going to enter in what we want to get from the higher level, and that's going to be the pipe hole diameter and pipe bolt holes. So those will be input. There are already some relations here in this model that control some other different dimensions in here. Let's drive the dimensions of the flange, put in a comment line. And again, from just checking out the model earlier, I happen to know that the D22 dimension should be equal to the pipe hole diameter. And the P6 dimension, that's the number of instances in the pattern, so that's going to be equal to pipe bolt holes. And now let's hit the save button and then exit. Yes, I want to incorporate the changes. Let's test this out. So I'll choose enter, select all and done select, and the new value for the pipe hole diameter. Oops, accidentally hit the middle mouse button. This is probably going to fail. Let me regenerate. Let's enter in the different values. All right. So the value for the pipe hole diameter, I want that to be a value of, let's try 25. And the value for the pipe bolt holes, let's try, again, just want to have something different. Let's try 10. And then Oh, we're getting a failure because I don't have the other different dimensions for the base extrude or the bolt circle updating properly. So let's go to the relations dialog box. And so I have the flange dimensions over here. Let me control some of the other different dimensions in here. I forgot to do that. And I happen to know that the D1 dimension is the flange diameter, and so that's going to be equal to D22, which I assign to the pipe hole diameter, plus 10. And the bolt circle diameter is D2. Let's make that equal to D22 plus 6. In this case here, I'm writing the relations right here in the relations dialog box. I could have also gone over to Pro Program to do that. So let me verify the dimensions and click the OK button. And let's regenerate. Let's enter in the different values. And I have 25 and 10. There we go. Big diameter, 10 holes in there. So always need to test your work as you're doing it. So now the pipe is working. Let's close out of there. Let me hit the regenerate button here. And let's enter in the different values for everything. And let's see, for the plate hole diameter right now is a value of 30. Yeah, let's leave that. We have 8 holes down on the plate. Let's see, 20 for the pipe hole diameter and 6 holes up there. And then for the height, 40. So now, it's asking me for a reducer program. Let's see. Because it's at the lower level as well. All right, so something tells me that I probably don't have what's going on at the reducer level being assigned its different values. So let me go back to the program. Let's edit the design. Something is probably missing in execute. So let's scroll down over here, past the default datums. Okay, so far I've only passed the height down to the reducer. Let's pass on the other different dimensions in here as well. And so let's pass on. Let's see, we have the pipe hole diameter. That's going to be equal to pipe hole diameter. Let's see, pipe bolt holes. It's going to be equal to pipe bolt holes. And let's see, we have the plate hole diameter. That's going to be equal to plate hole diameter and plate bolt holes. We want that to be equal to plate bolt holes. And I'm probably not passing values down to this as well. So let's add in our execute construct here. So we're going to execute part straight. And let's see, we want to pass to that pipe hole diameter. And that's going to be equal to pipe hole diameter. And because I screwed that up, I was getting into an endless loop, infinite loop of, hey, what are the values that you want for stuff? All right, so now this should be passing values into the individual components. Let's save, let's exit. Yes, I want to incorporate the changes. Let's enter in all the different values. And again, 30, that's good. 8 holes, 20 up at the top, 6 holes, and then height of 40. There we go. And now you'll see that they're updating together with each other. So everything is good down at this level. Let's now go up to the top level. And we're getting a regeneration failure. Let's hit the regenerate button. And let's enter in a bunch of different values. I will select all of them. You'll notice at the top level we only have 4 different ones because the height is being controlled in a subassembly. So let's hit done, select out of there. And let's see, diameter on the inlet side, let's do a value of 40. I always like to choose different values every time just to make sure that stuff is updating. Let's do 10 down at the bottom. Let's see, diameter on the outlet. Yeah, we can leave a value of 20 there. Let's do 15. And the number of bolts there, let's use a value of 5. And now again, we're being prompted, in this case here, for the dimension in reducer program. Let's enter in a value for the height. I'm going to enter in a value of 20. And there you see how everything updates. Got a problem with one of the nuts in there. That's weird. Okay, just FYI, the nut failure had nothing to do with the Pro program stuff. Turns out the nuts had some really weird constraints in here. They didn't do it the simple way of just coincident constraints. Hey, fixed it to hit the easy button, and now the nuts are not having a problem. Let's try regenerating and entering in different values again. Select all, and then done select. And let's change the inlet side diameter from 40 down to 30. Let's change the number of bolts down to 6. The diameter on the outlet side, let's use a value of 20. Let's make it 24. And the number of bolts on the outlet side, let's use a value of 6 there as well. And enter in a different value for the height. Let's use a value of 30 this time. And there we have a different reducer. And just like in the previous video, if you go to the model intent overflow command and then program, there's the instantiate option in order to create a family table instance in here. But again, that is how you can use Pro program at the assembly level with the execute construct in order to input values at the different levels and then pass them down to lower levels, individual components, or subassemblies within your model. I hope you enjoyed this video. For more information, please visit www.creowindchill.com. If you learned something from this video, please give it a thumbs up. And if you like this video, please click the subscribe button to be informed when new videos are uploaded. Thank you very much.